All right, Saxton, you want me to take a look at the log for a little bit of prop wash and see if I had any thoughts, so let's check it out. Okay, like any log, first thing I always look at is noise on the quad and see if there's anything that needs to be improved there. Debug mode notch was not recorded on this log, so all we have is the filter gyro data. Nevertheless, let's take a look at that. Looking at the gyro raw, or the gyro on the roll axis, it looks like the dynamic notch, looks like what you have on is the gyro low pass filter at 90, static notches are off, dynamic notch is turned on, and the Dterm notch is set to, or the Dterm low pass filter is set to PT1, and you do have the notch, the Dterm notch enabled. So a pretty classic 3.2.5 beta flight setup. What we can see on this is that the dynamic, I'm assuming there's a higher peak within here, and the dynamic notch is trying to kill that as good as it can, but it is letting through some of the peak motor noise up here around the 345 range, somewhere in there. That is getting through onto your P-term. So if I go to the P-term roll, you can see that's persistent there. And if I go to the D-term and look at that noise as well, you can see it's still persistent, and the D-term just magnifies it even more. And you can see it's magnifying any of this noise out here, 600 to 800. The D-term notch is cutting this down pretty well. So if I come to the practical sense, what does that look like in the log? So if I zoom way out on this log, you can see all the spikes in amplitude here. And if I zoom back into that and I do a marked point between the two, a peak here and a peak here, you can see that's around that 300 to 400, so 378 range. And you can see those jitters in there in the P-term, which is the red trace, and then even amplified even further in the D-term. Usually I'd like to see somewhat of a smoother P-term.
So inputting your filter settings into the latency calc tool that I have, right now you have the D-term notch on, and I guess what I'm postulating here is that instead of having this D-term notch on, which is only helping for the D-term and just kind of creating a valley there, you still have some higher end noise. You can see that's around half a millisecond of latency, so it's minimal. But instead of having that turned on, go ahead and turn that off, saving that time, and then go over and turn on, if you would have the 3.3 or 3.4 firmware, go ahead and turn on your stage 2 filter low pass, and then set that. You can see at 300 hertz cutoff, you're swapping that out. So now you got the half. So you didn't really save in latency, like you didn't reduce your filtering latency at all, but you're switching it from just the D-term to also be on the gyro, which then obviously impacts the D-term as well. And beneficially as well is that you're not just taking this notch out. You're going to set it at 200 or 250. I would probably go 250, I guess. I don't know, you could go to 200, you could play with it. And then that's going to help attenuate all this noise out here versus this notch is just doing the one, so you get a double stacking. I think that would be a better combination to hit this higher frequency noise. Okay, so now getting on to the PID tuning part of this. So I have my Blackbox set up with the RC command just for roll. We're only going to look at the roll axis, but the same applies to the pitch. Just for simplification purposes here, we're just going to look at the roll. So I have RC command, this is the stick inputs for the roll. I have the PID error, so this is the differential between what it's commanding versus what the gyro is reading. Then I have the P for roll, I for roll, D for roll, what the gyro is reading on roll, and then the PID sum. So we're going to take a look through to a couple of your prop wash spots in the recording. Okay, so as you saw in that video, that was your first spot of prop wash. So looking at the log on that, you can see our RC command is pretty much holding steady for roll. There's a little bit of input on roll, but not too much. And then we do have some PID area, so essentially the gyro is picking up that the quad is shaking back and forth and trying to adjust for it. Unfortunately, the classic answer is what I think you should do is bump up D-term. So if I go to your D gains here, you can see that your roll for your D is 26. I would just keep bumping that up and see where that gets. I think that's lower. 26 is lower than the default. The default, I believe, is 30 or 30. I think it's 30 and then 35 for pitch. So you're a little bit below the default, so you're in the safe zone there. I would just bump that up to C. Now let's just kind of break this down. So you can see this is the D term, and since it's measuring essentially the slope of the PID error, you can see it's starting to react and multiply up by the D gain at the sloping part of the PID error. So by pushing this higher, that's going to essentially make this amplitude higher. What happens is that the P or the D term and the P term are summed together in the PID sum, which is then pushed out to the motors, and you can see that that D term is basically telling the quad in advance of the full magnitude of the error to start reacting to compensate for that. So obviously if we have more D term gain, this is going to push this up. It's going to push each infinitesimal part. So this will be a little higher, this will be a little higher here, a little higher here, a little higher here, a little higher here. So that's going to push this up as well. It's going to make this more advanced of the actual slope of the line. It's going to make it a little bit more advanced in time, and it's also going to give it a higher magnitude. And then the P term's there to kind of follow and bring that slope back down until we get to a sum 0. So it's all about trying to essentially get the quad to react as fast as possible as soon as it starts to have a deviation in slope here from having a nice steady PID error. So in all cases, that's what I would imagine doing. The one thing with the filtering is if you can get a better handle on your filter, you can see how, like over here, for example, with smoothing turned off, that you can see that all that noise coming through, and it's getting, best way I would put it is kind of mixed signals because of that noise coming through on the gyro. So I think if you can address that better, you can get a more consistent answer out of the D term to adjust this PID sum, and you won't get these vibrations here. You can see where it's really trying to do its most work. It is resulting in a nice steady flow, at least in this part of it. But let's go look at another one. So here's another section of prop wash at 1:36 in the log, 1 minute 36 seconds in the log. And you can see here the D term is doing its job again, but it has a little bit more jagged output there. So again, hopefully the filtering will help with that. You'll have to. It's worth a test. I can't guarantee it's going to be it or not, but it's something I would try at least, and that's what you're here for, is my 2 cents. So that's what I would do if it was my quad. See if it works. Obviously, I would do a dump, keep this setting, and if things don't get better, just go back to this. As you can see from the logs, it's you're dealing with very little prop wash, so I think it's looking pretty good. For one final data point on this, I threw your log into the Plasmatree PID analyzer just to see what the result would be. What we're looking at here, we're going to focus on this bottom graph. Essentially, it looks at the input, the RC commands, and then also looks at the gyro output, maps that, and then gives you some analysis lines down here. If the roll rate is less than 500 degrees per second, that's the blue line. If the roll rate is more than 500 degrees per second, which this symbol is off, it should be flipped around, it is the yellow line. Same thing then for pitch here as well. You can see what we want to have is a nice sharp steep line to get up to 1, and it just smoothly goes right along 1. The ideal situation is it juts up to 1 and just doesn't go over 1 at all, and just goes right along 1 for a strength the whole way through. So you can see it looks pretty good. If you got a lot of wavy lines on the blue, that would be meaning that your D term needs to be higher. So when you're in a roll rate less than 500 degrees per second, you can see there's a little bit of that in the pitch, so your pitch may need to go up in Dterm a little bit more than your roll. However, in your logs, it looked like your roll had more prop wash, but take a look at it for yourself. Now, when you're requesting higher roll rates or pitch rates or flip rates, you can see there's a lot of oscillation there. So increasing your D gains should help with this as well for the higher roll rates. Like I said, you can see on the blue line it's not too bad. One last thing, this does show that your I gains are a little light for your pitch, roll, and yaw. When the I, when this is not coming up and hitting 1 for strength, that's an I gain thing if you read the Plasmatree direction. And something to consider, I noticed you had your anti-gravity gain set to 5, so you probably never notice it. So maybe, drop that down to like 3 or 2.5 or something. And then if you see it bobbling, bump up your I gains as well. But per the mathematical analysis by Plasmatree, your I gains are a little light. All right, hope that just gives another point of reference. Yeah, thanks for sharing this log. I hope some of this information was helpful. And do let me know if it makes it any better or worse. I'd be interested in knowing. And again, thanks. I hope this helps.